So we look at this geometry problem where we have a square ABCD where an interior point P such that the angle here PDC and PCD are both 15 degrees. We want to prove the triangle PAB here is regular. Last time we did an analytical geometry using trigonometry to prove this, but today we're going to use pure geometry method. Here we're going to have 4 different methods. For the first method, what we can do is to try to do a vertical line so that this is perpendicular here. All right, let's call it H, the point H here, right? This is going to be 75 degrees. We try to construct an angle with, let's say, 60 degrees. Call this point Q. So that is, we're going to construct AH perpendicular to PD, and we're going to construct so that Q dP equal 60 degrees. Let's chase some angles here, right? So we know that this remaining one must be 15 degrees, right? And so this one here must be 30 degrees because what we have is this is a perpendicular, this is 90 degrees, right? So the 60, 30. So, and here, of course, you're going to see this is going to be 15 degrees. Since the exterior angle equals the sum of the two. So what we have is from here, we know that the way we constructed, we know that angle DQH equals 30 degrees. So we're going to know that the angle, let's say this is angle 1, here is going to be the difference of the exterior angle, which is angle DQH minus the 15 degree angle ADQ. So which is 15 degrees. So now here, using the property of the right triangle with special angles here, right? So that is the angle 30, 60, and 90 degrees. So we know that DH is going to be half of what is called DQ, right? So we have DH is going to be 1/2 of DQ. All right. Now let's look at 2 triangles here, which is we're going to use a different highlight color. Okay. So what do we observe that for the angle, a triangle ADQ versus triangle DCP, we observe that the 2 sides are equal to each other. These sides equal to each other, right? And they both have 15 degree construction here. So sides, angle, so they're congruent. So these 2 triangles are congruent. So which means we conclude that the DQ is going to equal to PC, which is equal to PD, because PDC is an isosceles triangle. So from here we know that the DQ here is equal to PD, right? So this is 1/2 of PD. So what do we have? So let's look at this. We're going to erase certain annotation here, but let's look at this triangle here, A, PD here, right? Now we do have a perpendicular line here. This is a perpendicular line. And earlier we said that DH is half of PD. In other words, DH is 1/2, H is a middle point. Now when H is a middle point and perpendicular, we know that this angle bisector. In other words, this angle 2 must be congruent to angle 1. And they're both equal to 15 degrees. So which means the angle here's total is 30 degrees, and the remaining one here, this angle here, must be 60 degrees. Now, similarly, for the right hand, you can use the same argument to show that this is also 60 degrees. Then we have proven that, indeed, triangle PAB is a regular triangle. That's method number 1. All right, so let's do method number 2. Before that, we want to clone the picture for method number 3. Now, a common way to prove is that you will try to construct a regular triangle from the same side. So we want to prove this triangle here to be regular triangle. Now, we're going to construct a regular triangle. We assume that it's going to be a different point, P prime, right? So the different point, let's call that point is P prime. Now, if we can prove that the P and P prime are the same point, then we're done. Now, that's a very common proof techniques. Now, how do we do that? Now, if we do, let's say this is P prime, right? Now, in order to make it simpler, let's call this point is P prime. It's not P, right? So we construct P prime. If somehow we can show that this angle is indeed 15 degrees, then we're done. That means the P prime happens to be the point P. So which means, indeed, P prime AB by construction is a regular triangle. But if P and P prime are the same point, then PAB is also a regular triangle. That's a proof, okay? So this is proof of the idea. So let's do that. So in other words, we constructed, so this is a regular triangle, yeah? And so that the angle is 60 degrees. So this is going to be 30 degrees. This is 30 degrees. And of course, we know that this is an isosceles triangle here because all sides is from a square, right? Equal to each other. So this must be 75 degrees and 75 degrees. And of course, this would be 15 degrees. Now, similarly, we use the same argument. This is going to be 15 degrees. So if from the point CD, from this point CD, if you construct 15 degrees, the middle point P and P prime must be the same point, right? Because by the fact that if the two angles have angle side, one side and two angle associated with the side, then we have congruent triangle. So we have the proof, all right? So I didn't write the words, but let's write it down here. Let's construct. Okay, so construct P prime AB, P prime AB as a regular triangle From there, we know that the angle DAP prime and CBP prime are both equal to 30 degrees. Okay, and we further conclude that the ADP is 75 degrees, and thus the P prime, this was the P prime, right? DC equal 15 degrees. Now, similarly, we prove that the P prime CD on the other side is also 15 degrees. And we further conclude that because given point P satisfies this property, and P prime must be the same point, coincide with each other, right? So this is the second proof. We just proved that it is a regular triangle. Let's try the third proof. What we want to do, let's move this away. Now this time we also construct what is called a regular triangle, but we're going to construct it using the size CD here. Because it's symmetrical nature, this must be perpendicular. Let's move a little bit. All right, this is by construction. So we construct regular triangle that is QDC, and we make the connection of P and Q. So what you can claim that since this is regular, so this size, this size, this size, they all equal to each other, and they have a common size here for these two triangles. So we see two concurrent triangles here. So one is this one, yeah, and the other one is this one. They are congruent, right? So this is because three sides are equal to each other. So triangle ADP and QDP triangle, they are congruent. Okay. And earlier, because of symmetrical property here, right? So this is the first key. We know that earlier, because by its construction, we have this isosceles triangle here on one side, isosceles triangle here on the other side, right? By the construction, right? So we know that PQ, it is bisector and perpendicular, right? Bisector and perpendicular line. Perpendicular line of CD, right? So, which means the angle here is going to be 30 degrees. Okay, by symmetric properties. Now, earlier we have showed that the congruent is not because of the size, sorry. The congruent is actually because of the side angle. This is 75 degrees. This is also 75 degrees. And this is common side. So from there, we know that these sides equal to each other here. By symmetric argument, so in other words, from this one, you conclude that PA is equal PQ. But from the other side, you use the same argument here. So this is congruent to this triangle here, right? So which means this gonna equal here. So later you deduce that this equal to PB. And the all equal to the side, which is AB. Okay, this is a regular triangle. So we have proven that this is indeed a regular triangle. This is the fourth method. And it's a third or fourth? Oh, this is a third, okay. I lost track of it, okay. And now yet another proof method. What we can do in this one, we try to extend the 9 here, right? Yeah, and we try to extend CP here. How shall we name the number? Let's say this is E, this is F, right? Okay. We try to draw a perpendicular line from A, just like earlier, right? This is perpendicular line. Let's call it, this is H, right? This is H. And we'll try to draw a perpendicular line here. Okay. Let's call it, let's say G, right? This is perpendicular here. This is also perpendicular, right? So since we're given that this is 15 degrees, so this angle is exterior angle, this angle must be 30 degrees. Okay, so 30-degree angle here, we have a triangle here. right triangle with 30 degrees. So which means we have CG is going to be half of PG. Alright, so that's what we know. Now we want to show some congruent triangle here. Now one thing we know that this is right triangle here. We have this angle here must be the 90 degree minus 15 degrees is 75, and this is also 75. So we do have two right triangles are congruent to each other because the hypotenuse is the same. So that is the angle ADH, and I mean the triangle ADH, right? And DCG. They are congruent to each other, right? Okay, so which means DH is going to equal CG, and that's equal half of earlier. This is not PG. This is half of PC. Okay, because this side here is half of the PC, and if half of PD. Now we use earlier same argument. We're saying that this edge is a midpoint, right? So edge is kind of midpoint of PD. Because DH is half of PD, right? And this is a perpendicular line, so we conclude that this must be the angle bisector. This angle equal to each other. And of course we know that this is 15 degrees. So this must also be 15 degrees. So the whole thing is 30 degrees, and this is 60 degrees. Okay? Now using the same argument, this is 60 degrees. Okay? Just like in earlier method, that's PAB is regular. Okay. So we have used 4 different methods to show that the triangle PAB is regular. Alright? So hope you follow the steps and think about it. There could be other methods, I'm sure, of these classic geometry problems. Alright? Hope you enjoyed the video. Please like, share, and subscribe to the channel.